Hello, Hornets. We are going to be talking about related rates today. And related rates is a fairly big concept because there are lots of situations where things change with relationship to others. For example, let's take the formula triangle's area. Area of a triangle is 1/2 base times height. So we can clearly see that the area is going to be a factor of the base and the height. But what happens if I want to find the change in area based upon the change in height? So what we're talking about is a change in area in terms of time. And that's what a related rate is going to mostly be dealing with. Over time, how are things changing? And you'll notice this is going to give me dA dt, the rate of change of the area in terms of time, and it will be 1/2, and now we have the product rule, dB dt times h plus b times dH dt. You'll notice all I've done is the product rule with this implicitly. So implicit differentiation is part of the related rates. And we now have two related rates that are changing the area in terms of time. There's the 1/2 height times b prime and the 1/2 base times height prime. So two distinctly different derivatives that are adding or affecting the area of this triangle. Now, all related rates is having bits of information about certain situations, and then what's missing, finding whatever's missing. So if I know the rate of change of the area, and I know the rate of change of the base, I can find my rate of change of the height at a moment when the base and the height are known. That's a related rate. Now, the most common related rate that we work with in this class deals with the Pythagorean Theorem. Consider a car is moving toward an intersection and another car is moving toward an intersection. So we have two cars. Let's say we have car A and we have car B. Car A we're going to have moving at 15 miles per hour, and we're going to have car B moving at 25 miles per hour. Alrighty. Now you'll notice that as these two cars are moving together, this hypotenuse is going to change positions. So we have three different rates. We have our y value, our x value, and our h value, and therefore our y prime, which we have as 25 miles per hour, our x prime, which we have as 15 miles per hour. Now, please be aware, because that distance is closing, because it's getting smaller, the distance is decreasing, we have a negative rate. Even though the rates themselves, the distances themselves might be positive. So let's just take a look at, say, I have 4 miles away here, and I have 3 miles away here. According to my Pythagorean theorem, h is 5 miles away. Now we're asking, at what rate are the cars getting closer to each other? And this is a Pythagorean theorem. So what we have is, we have our x squared plus y squared equals our hypotenuse squared. And if we do a related rate in terms of time, I'm actually creating a parametric equation. 2x x prime plus 2y y prime equals 2h h prime. And from this, we get what h prime is simply by dividing by 2h. H prime has to be the x prime plus y prime divided by the h. Notice that the 2 has been reduced. And we have everything we need. We have x prime and x, we have y prime and y, and we have h, which means that we can substitute in and we can solve for h prime, the rate of change at which the two vehicles are approaching each other. Now, these could be as simple as a balloon is floating into the air at a certain rate. And we know how far we are from the balloon, we know how far the balloon is up, and we can therefore find a related rate. Now, anytime we're using a right triangle, we're going to be dealing with the Pythagorean theorem of x squared plus y squared equals h squared. Now, depending upon the shape that we're dealing with, such as a sphere, a triangle, a cone, a frustrum, whatever it might be, all of these have formulas from which we can take a derivative in terms of time. As long as we do it implicitly and we make sure that we follow all of our appropriate rules, it should be a matter of simply plugging in what we know in order to find what we need. Now, that's the whole idea behind a related rate, and it's going to take some practice and time for you to get used to it and be able to do it without a problem. So please be patient with yourselves as you work with these. We will continue to work with them over the next several days, and you will improve. Thank you very much. This has been an introduction to related rates, and it's my hope that you have some idea of what we'll be doing next. Thank you. Be well and be safe. Take care. Thank you, Jorge.